Bismillahirrahmanirrahim. So,
रिकॉर्ड का जैसा रिकॉर्ड जी
so yesterday we were discussing the LS coupling of the helium, and we have discussed what is the symmetric and antisymmetric wave function. So now we have to apply that symmetric and antisymmetric wave function on the term values of the carbon and oxygen. So I am sharing my screen over here. Okay, so now we are discussing the LS coupling of the carbon atom. The Z value of the carbon atom is a 6. So it means its electronic configuration is 1s2, 2s2, and 2p2. So the total number of 6 electrons over here. 1s2, in the S there are 2 electrons, which is the complete orbital. 2s2, so there are two electron in the s orbital. This is again complete orbital. The third one is a 2p2, so there are maximum 6 electrons in the p orbital. Here we have a 2 electron, so this is incomplete orbital. So the both electrons of the p orbital can interact with each other with the LS coupling. So in this particular case, we say that the both p orbital valence electron interact through LS coupling. In this case, L1 is equal to 1 because one of the electron in the p orbital. This will not contribute into the coupling. Here 1s2, 2s2, they will not contribute into the coupling because they are filled orbits. The filled orbits is not contributing in the interaction. Only the valence electron over here contributing in the coupling process. So now in this 2p2 electrons, the L1 is equal to 1, L2 is equal to 1. So if we combine them, it gives you 0. If you combine them, it gives you 2. So subtraction gives you 0, addition gives you 2. So as a resultant, the series terminates from 0 to 2. So the L value is 0, 1, 2. For 0, it is the s orbital. For 1, it is a p orbital. For 2, it is a d orbital. So s, p, d are the orbitals here. So now the spin is 1/2, spin is 1/2, the spin of both electron is 1/2. So the total spin is either 0 or 1/2. 0 gives you the both are in the opposite direction, means they are anti-parallel to each other, and 1 gives you both electron have the spin parallel to each other. So now here, the term value for the carbon 2p2 as L1 is this, S is this. So here total L is equal to 0, 1, 2, and total spin is 0. The first combination is this. Because there are two possible values of the spin, 0 or 1. So in the first combination, we are taking 0. So in S is equal to 0 here, the term value will be equal to 1 because multiplicity will be equal to 1 because here if we put it 0s, so the 2s plus 1 is equal to 1. S is equal to 0, 0 multiplied by 2, 0 plus 1 gives you 1. So 1. L is equal to 0, S, L is equal to 1, P, L is equal to 2, D. So the multiplicity of all these three is equal to 1 because the spin is 0. And the J value is equal to 0 plus 0 gives you 0. 0 plus 1 gives you 1. 0 plus 2 gives you 2. So when the spin is anti-parallel, it gives you the term value which has a 3 values. One value is 1s0, the second value is 1p1, and the third value is 1d2. So these are the three term values when the both electron have a spin anti-parallel to each other. So now the second option is that if the electron spin is aligned in the same direction. So if the spin is aligned in the same direction, then what happens here? So here when the spin is aligned in the same direction, so the total spin is 1. Again, L is equal to 0, 1 and 2. So for S is equal to 1, the term value which is equal to 2S1, S is equal to 1 multiplied by 2, 2 plus 1, 3. So the term value is 3. So in general, if the spin is 0, it gives you the singlet. If the spin is 1, it gives you the triplet. If spin is 1/2, it gives you the doublet. So here the spin is equal to Here the spin is equal to 1, so therefore the multiplicity is 3. So now we are looking at the total J value here. So J is equal to 1. So 1 gives you 0 plus 1 is equal to 1. So here L is equal to 1, S is equal to 1, 1 plus 1 gives you 1 plus 1 gives you 2, 1 minus 1 gives you 0. So here that J values is equal to 0, 1, 2. So the term value is equal to 3p012. For the other value, spin is equal to 1, L is equal to 2. The term value is equal to 3d123. So because L is equal to 2, it is a d orbital. S is equal to 1, it is a triplet. And L is equal to 2 plus J is equal to 2 plus minus 1 is equal to 1 and 3. So the series goes from 1 to 3. So 1, 2, 3. These are the three values of the multiplicity when the spin of both electrons are aligned in the same direction here. So now we are looking at the term value. So this is the J for this, this is the J for this, this is the J for this. Clear? So now what we have observed these different values of the multiplicity, different values of the term values when the electron is in the ground state, because 2p2 is the ground state of the electron in the carbon, because its configuration terminates at 2p2. So 2p2 both are the valence electron and we call it as a ground state electrons. So now among these, so this total term values gives you 1, 2, 3, 4. 4 plus 3, 7, 7 plus 3, 10. So here the total possible term values are 10. Now the question is that, which is very much important question, whether these R levels are possible or not. This is the important thing. So this shows that the 2p2 electron, the total possible terms are 10. In quantum mechanics, the identical particles and multi-electron system of the wave function psi remains unchanged. The wave function is said to be symmetric with respect to the interchange. If we change the sign, the wave function becomes anti-symmetric. So now, according to the Pauli-Exclusion principle, the total wave function must be equal to the anti-symmetric. Yesterday we have discussed that a electron is the fermion. For the fermions, the total wave function must be anti-symmetric, and that level is possible. If the wave function is symmetric, then that level is not possible. So this is for fermions, and electrons are the fermions. So therefore, the electron follows